My name is Advait, and I would like to present to you my project, BioSense, which is a novel method for above-ground biomass detection in forests through the use of machine learning, with the ultimate goal of detecting carbon energy flow to enhance conservation efforts. So the dense forests in our home state of California have long been treasured for their ecological significance, breathtaking beauty, and vital role in mitigating climate change. However, these once thriving ecosystems are now facing significant challenges, including destructive wildfires and extensive logging practices. The consequences of such events have far-reaching implications, affecting not only the environment, but human lives and the economy. And specifically in the last 3 years, California has witnessed an alarming increase in the frequency and intensity of wildfires. These catastrophic events, in addition to logging and other forms of deforestation, not only devastate the natural landscape, but also release massive amounts of carbon dioxide into the atmosphere, which severely aggravates climate change. Due to this, negative effects on the forest ecosystems and the environment are often widespread and difficult to track, making it harder to take action to reduce the negative impacts. To effectively address these challenges, many experts have proven that it is crucial to accurately quantify and monitor the above-ground biomass of forests. Above-ground biomass serves as a vital indicator for estimating carbon release and sequestration, which in other words is the carbon energy flow through the ecosystem. Above-ground biomass thereby provides insights into the overall health and carbon balance of forest ecosystems. The existing methods for measuring above-ground biomass usually use destructive sampling, which requires cutting down representative trees and measuring attributes like crown and trunk dimensions. However, this method can be quite invasive and exhausts a large amount of resources and time, and is also very limited in scalability. This is why I decided to approach this problem with machine learning, a subset of artificial intelligence. So I developed BioSense, a custom-trained machine learning model to provide estimates of above-ground biomass using satellite imagery. The developed system will enable faster and less destructive assessment of carbon release and sequestration in forests, empowering landowners and policymakers to make more informed decisions for effective forest conservation. So getting down to the mechanics and the code of the model I used was based on the ResNet 50 machine learning architecture, which is a 50-layer convolutional neural network. The training data set consisted of satellite imagery from California forests over a 9-year period as features, and the LiDAR-based above-ground biomass for the same region, LiDAR, were the labels or outputs. This means that after training, when the model predicts something, it expects a satellite image as input and outputs an estimate for above-ground biomass, similar to a thorough LiDAR scan. So let me show you a quick example here. So when the satellite data on the left is fed to my model, the output would be the image on the right, which shows the above ground biomass, just like LiDAR would, in addition to some measurement data points like kilograms per meter squared weight. And although obviously this would be in a much less time than thorough LiDAR scanning take, LiDAR scans, especially for forested areas with dense areas within them, would take a long amount of time. So this way, any area with satellite coverage can be fed to BioSense with the ability to predict the amount of above ground biomass without the need for complex LiDAR systems. So this ideally would help scientists, researchers, decision makers understand the amount of carbon energy flowed through a certain area and allow them to take action to create a greater impact on the sustainability of a select region. So to encompass all of my results and findings from my project, I would like to outline 3 major conclusions. Number 1 is accessibility and scalability. Due to the use of machine learning, BioSense has the unique ability to be scalable while also staying accessible, meaning that transitioning to studying from a smaller area to a larger one is easily manageable, unlike current methods. Number 2 is the environmental and economic impact. By leveraging the data provided by BioSense, policymakers can prioritize sustainable forestry practices, promote reforestation initiatives, and use this data to effectively combat climate change, helping both the environment and the economy. And finally, number 3 is the real-world interest and implications. In hopes to validate the real-world interest in my project, I had reached out to a private lab in Norway, and who I saw was interested in doing something similar for their dense land areas and forests. And I got a response back saying they were quite interested in my project, and they expressed their interest by stating that BioSense had a sense of practical application to their current efforts. So I'd like to end by saying that I'm delighted to announce that I'm currently engaged in talks with this lab. So thank you for listening.